Hey, hello friends, and welcome back to another video of this series. In this video, we are going to talk about diodes. So we'll be covering the basic and the types of diodes, and we'll be going through the application circuits. We'll be talking about current direction control, over voltage protection, voltage regulation, reverse polarity protection. And this video is part of our ongoing series where we are building this wonderful hardware from the scratch. In the last videos, we have talked about different components in details. Go check out those videos if you haven't watched those. And if you see this hardware, right, so we have all these diodes. So these are the protection diodes. Then we have some special diodes which we are using it for ESD protection, which is being connected to the CAN transceiver CAN line. And then we have diodes which we are using basically to protect this for reverse polarity. So let me show you, right? So in this video we are going to see how you will be able to select a diode like this, which is acting as a reverse polarity protection diode. So if in case you are swapping, or if by mistake you are reversing the whole connection, okay, to your circuit, this diode will make sure you are not spoiling this hardware. Okay, in this video we'll be covering all these diodes. So we'll be talking about how you will be using a diode with your USB type C connector so that there is no reverse current flowing through. So if you see over here, this is the CAN transceiver which we are using, and we are using this at CDSOT 0502B. Okay, and this is basically a bidirectional TVS diode. Okay, before going ahead with the video, I would like to thank Altium for sponsoring this video series. So Altium is one of the best PCB designing software available. Altium offers Altium 365, which is one of a kind offer that comes from Altium, where you can build hardware from scratch with multiple stakeholders involved. So it can go start from the requirement and go till production, where you'll be able to manage different aspects of the design. It can be a CAD, it can be the BOM management, it can be the schematic part library, and finally the QC and testing. So go check out Altium 365. I have a link in the description. You can go through that link. You can click over here to watch the full video in terms of how what features that comes with Altium 365. So starting with the definition of diode. So a diode is a semiconductor device that allow current to flow only in one direction and blocks the current in the opposite direction. It consists of two terminals. The positive one is anode and the negative one is cathode. And the diode core is made by a p-n junction. So if you see, right, as a principle, a diode application is defined by the flow of current, where it only allows conduction, or I can say the flow of current in one direction and blocks in the opposite direction. So this is how the behavior of a diode is defined. And whenever this p-n junction, right, is changed, or based on the properties of this p-n junction, different types of diodes are being evolved. So you have this general purpose diode, you have Zener diode, you have tunnel diode, Schottky diode, Varactor diode, diac, triac, SCR. Then you have these LEDs, which are the light emitting diodes, which is a very common, which you would have used in any hardwares. And then you have a photodiode. So photodiodes are very common in your solar panels and all. Okay, so in terms of symbol representation, you will find a different representations also, but this is how generally a diode is being represented. Coming to the representation of a diode, so current direction control is achieved based on uh, what sort of a biasing this diode is in. Okay, so whenever the diode positive terminal, okay, the anode is connected to the positive terminal of the supply, and the negative terminal of the diode, which is the cathode, connected to the ground or either to the load or a low voltage side, okay, then this becomes a forward bias. In case of forward bias, the current will flow and this acts as a conducting element. Whereas in case of a reverse bias, where if you see the negative terminal is connected to the positive terminal of the diode, then this behaves as an open circuit. And this you can understand better here. So if you see this D1, right, is connected to the 5 volt, the positive terminal is connected to the 5 volt and the negative terminal is connected to the ground. And here the considered voltage drop across the diode is 0 volts. Now the equivalent circuit for this would be something like a wire directly connected, right? Whereas whenever it is reversed bias, that means the positive terminal of the diode is connected to the negative 5 volt and the negative terminal which is the cathode of the diode, is connected to the positive 5 volt. So this becomes as a reverse bias, and this will act as an open circuit and there won't be any current. So this is how you will be able to control the current flow. And the same application goes when you want to design something for a reverse protection. Okay, now let's see all the different applications of the diodes quickly. So you have general purpose diode, which is used for reverse polarity protection. Then you have Zener diodes, which are used for over voltage protection. So we are going to see this in detail. Then you have TVS diodes, and TVS diodes are used for surge and ESD protection. You have Schottky diodes. So Schottky diodes also solves for the reverse polarity because it has a fast switching, and also the voltage drop across the Schottky diode is less as compared to the general purpose diode. So Schottky diodes are the most common for the reverse polarity protection. You have flyback diodes, which are basically for the inductive load protections, and we are not going to discuss this in detail in this video because in the upcoming videos we are not using any sort of a flyback diodes. And the last one is the ESD protection diode. So these are used for any sort of electrostatic discharge that comes. Okay, so if you talk about TVS diode and ESD protection, so these are basically used for any sort of a surged electrostatic discharge for any of the signal lines. Okay, so it can be a CAN bus, USB port, or even your power lines, general purpose input output pins. Okay, so let's go ahead with understanding how this reverse polarity protection. I think this is one of the very common situation where you will land up. So sometimes you will design a hardware and by mistake you will be connecting the positive terminal to the negative terminal and negative terminal to the positive terminal, right? That means you'll be connecting the power source in a reverse direction, and eventually if you don't have any sort of a protection on your hardware, the PCB will get spoiled or burned. Okay. Now to protect this as a behavior, you can have the reverse current protection circuit. So as we discussed in the forward biased, it will be able to conduct current, but whereas in the reversed bias, it will not be able to conduct current. Okay, so that will act as an open circuit, and basically the potential across the circuit would be there, but since it is an open circuit, right, there won't be any current flowing. And Schottky diodes makes an excellent choice for the reverse protection diodes because it has a low voltage dropout. Now, it doesn't mean, let's say, if you have designed something for a 9-volt system, right? And in that 9-volt system, you are using a diode. You cannot have a reverse current protection, let's say the 9 volt, and you suddenly applied some 20 volts, okay, in a reverse direction, and the circuit will get damaged. We are just talking about when you are reversing the same sort of whatever the input this diode can take, you are basically reversing that input. So this is where this reverse current protection will be able to help you. Okay. So when it comes to overvoltage protection, we use Zener diode. So Zener diode is a special type of semiconductor diode which operates even in the breakdown region. If you see, so whenever it is been reversed biased, right, you will see a constant Zener voltage. Okay, and in this region is basically where your voltage clamping happens. So if you talk about a circuit like this, and if you see over here, right, the ground is connected to the positive terminal of the diode, and this is being reversed biased because this is the input. It can be a signal, it can be the power. So here if you see that input is being connected to the negative side of this diode, and this is a Zener diode, and it is operating currently in a reverse bias. Okay, so if it is rated for a 5.1 volt Zener diode, right, so beyond 5.1 volt, what will happen, it will get into this breakdown region. Okay, and it will clamp that voltage to 5.1 volts. So the voltage to this DA0 will not exceed 5.1 volts. So let's understand this in details. So if you see this circuit here, we are using 1N4009, and this is like a 6.8 volt Zener diode. And if we go through the specs, so here you will be able to find uh, diodes, Zener diodes, okay, with low noise, and here are the series. So we are talking about 1N4099, which is the most common one, and the nominal voltage, Zener voltage is 6.8, whereas the maximum it can have is 7.14 volts, where the maximum Zener current is around 35 milliamps. So let's again go back to our slide. So if you see here, the R1 and D2 are the two components protecting the output from the overvoltage protection. So basically, this across this D2, you will be having your protection circuit or the main circuit. So what happens whenever this voltage goes beyond the rated voltage, which is the general voltage of 6.8 volt, okay, this will get into a reverse bias breakdown region, and it will be in the constant voltage region, okay, and that output will be clamped to the maximum of 6.8. So if you see here as an example, if the input is 6 volt, the output will be around 6 volts, okay, and it is operating in a forward bias region. So if you talk about why there is a voltage drop of zero point 0.1, 0.001, that has been because of this resistor. Across this resistor, there will be some potential drop. And when it goes to 6.8, you can see it is maintaining 6.78. So this is 7.5. And if we talk about this Zener diode, right, so this has been in reverse bias. Now, the moment it is in reverse bias, it will make sure the voltage across this diode is 6.8 and it's not going beyond that. So this is how it will be able to clamp the output voltage, and it will protect the circuit from a over voltage. So now the question is, what would be the V1 max? Okay, so it cannot be right ki if you have something like 6.8 volt and you are able to give some 20 volt, 25 volt, and still it will be able to clamp. So there is a limit, and that limit is basically defined as a combination of what is the current that flows through. So it has a maximum voltage range, okay, and so the general voltage which saw the nominal was 6.8 volt and the maximum was 7.1 volts. So let's take 6.8 volt as the nominal one, and there was a general current of 35 milliamps, and we have this series resistance at 100 ohms. So the moment the circuit is there, right, you will see the same current flowing through this and this. So for the maximum general current, which is the 35 milliamps, the voltage drop across this R1 would be 100 ohm into 35 milliamps. And if you see V1 max, or the V1 would be the sum of the voltage here and here, and that is what is been represented here. So the maximum voltage that can be supplied for this given circuit would be around 10.3 volts. Okay, so this would be the maximum voltage that you can supply, provided you have this having a current of 35 milliamps. Okay, now, when your load current increases, this value might change, but as a combination, this is what the maximum voltage would be. So let's go ahead with the TVS diodes. So TVS diode is transient voltage suppression diode, which is a type of semiconductor device designed to protect electronic circuit from transient voltage spikes, and these are caused by lightning strikes, electrostatic discharge, or power line crosses. So whenever a transient voltage exceeds a certain threshold, the TVS diode will absorb and dissipate that excess energy, thereby protecting sensitive components in the circuit from damage. Now the key characteristics of a TVS diode is basically the clamping voltage, the voltage at which the diode begins to conduct and limit the transient voltage to a safer level. Peak pulse current, which is the maximum current the TVS diode can handle during a transient event. Response time, the time it takes for the TVS diode to react to a voltage surge. Then you have a breakdown voltage, the voltage at which the diode starts to conduct, typically higher than the normal operating voltage of the circuit it is protecting. Okay, so this becomes a critical, that is the breakdown voltage. And in terms of capacitance, the level of capacitance the diode introduces to the circuit. Low capacitance is desired for high speed circuits. Now there are different types of TVS diodes, and there are like unidirectional and bidirectional. In case of unidirectional, it protects the circuit with a single power rail, example like DC circuits and all. In case of bidirectional TVS diodes, so these are common for your signal lines, where it protects the circuit with AC power or signal lines that can swing both positive and negative. So in all the USB CAN, you will see the bidirectional TVS diodes. Now the question is how to select the right TVS diode. So when selecting a TVS diode, right, for a specific application, these are the different factors that needs to be taken. So we already saw the characteristics. So based on those characteristics value and your end application, you need to select. Now if we go back to what we are using in our design, is basically we are using this we are using this uh, TVS diode, which is a bidirectional TVS diode, and it provides ESD protection and surge protection for a high speed data ports, and it meets these standards. So these are the different standards, which is IEC 61004-2, then 4-4 EFT, and then 4-5. So these are the few requirements you will get whenever you are designing a circuit, right? So immune to any ESD or any electrostatic discharge, you will have these standards, and you have to select. So if you see, the transient voltage suppressor array offers a working peak reverse voltage of 5 volt and the minimum breakdown voltage of 6 volts. Okay, and here if you have different uh, parameters and their value, so the peak pulse current, right, is like 8.5 amps, and then you have this ESD based on air and contact, which is like 22 kilovolts and 15 kilovolts. Okay, and this is the operating temperature and all. So once we start on our basically CAN trans receivers, we will be going through multiple options, okay, which all TVS diodes to select, and there I think the concept will be more clear. And let's get back to this diode. So we talked about this diode, right? If you see this D15, which is basically the Schottky diode. Okay, so here we have selected the Schottky diode, which part number is this. Okay, so this is like since we are making something that can work for 24 volts and go till 30 volts, right? So we can go for something that takes 40 volts and a 3 amperes current, and you can go through the spec sheets. It's nothing fancy over here, but you'll be able to see what is the peak repetitive reverse voltage. Okay, so you have like 40 volts, and yeah, and the number of basically you have some standards over here, then you have some ESD rating as well. Now let's go back to the circuit. So if I show you here, right, so we have selected this as 3 amps and 40 volts, right? And where we are talking about our voltage input is 6 to 28. So if in case you are reversing the polarity of the input supply by mistake, this diode will make sure that your hardware is getting protected. This section of the supply is of the PCB is getting protected, so it will not basically conduct, and it will act as an open circuit. So this is all about the video. In the next video, we'll be talking about few other concepts, and we'll start capturing the schematic, and we'll be starting with the Altium Designer tool, how to use it from scratch. So thanks for watching. See you in the next video. Thank you.